Okay, so since we didn't have our class a while ago, this is the recording that I promised you for this particular topic. So again, we will discuss perfect square trinomials, factors of perfect squares trinomials. This is the fourth factoring technique that we will be having. So from the name itself, perfect square trinomial. So as you can see here, we will be involved with perfect squared numbers as well as trinomials. So later on, let's see how are we going to work with perfect square trinomials. So the process, perfect square trinomial is the result of a square of binomial. So just like what we have established last time, we have said that factoring is the reverse process of multiplication. Then, perfect square trinomials are results of squaring a binomial. So ibig sabihin, nanggaling po siya sa square of a binomial. A perfect square trinomial is from the result of a square of a binomial, which is a special product. Steps. We have here 3 steps involved in factoring perfect square trinomials. First, get the squares of the first and last terms. Second, use the sign of the middle term of the trinomial between these roots. And third, raise the binomial obtained in step 2 to the second power. So you can pause this video if you would want to copy this particular step so that later on you can see how are we going to work with this step. So I have here highlighted the things that you should be familiar with the steps. So square roots, the sign of the middle term, and then raising the binomial in the second power. So those are the things that you should be mindful with this particular factoring technique. So let's get started. As I have said a while back, factoring is the reverse process of multiplication. Then, we will be engaged here with 2 examples and for a review on the multiplication of polynomials. We have here 7m minus 4 squared. So as you can observe, this is a square of a binomial. So again, this is a square of a binomial. How did we identify this as a square of binomial? It's a square since it's raised into 2, and then it's a binomial since there are 2 terms present on the polynomial. So it's a square of a binomial. And then you can also remember that we have a general form for the square of a binomial, which is a squared plus 2ab. Again, so a squared plus 2ab. Sorry. So a squared plus 2ab. Plus b squared. So this is the general form of the square of a binomial when we try to evaluate this one. So just like what we have last year, actually we have discussed this one. Meron po tayong a squared plus 2ab plus b squared as the general form. We have already here the results. So if we try to evaluate 7m and we get its square, this will be 49m squared. The 7 squared is 49, m squared is m squared. And then the second term, for our last term, we have here 4. That's why if we get the square root of 4, or if we square 4, we'll have positive 16. But sir, what about the middle term? We have here a negative sign, so the negative symbol will still be followed here. And then we have here the rule 2ab. So if we try to evaluate with the rule 2ab, this is a, this is b, right? 7m multiplied to 4, that would be 28m. And then you need to multiply again by 2 since you have a 2 here. So that would be 56m. So that means this particular answer that we have here will be considered as a PST, or a perfect squared trinomial. And you note here, we can easily observe the general characteristic of a perfect square trinomial. The first term as well as the last term are perfect squared numbers. 49m squared is a perfect square number. So if we try to extract square root, we will have 7m, which is the same with the first term of your binomial. 16 rather, on the other hand, is also a perfect square number, which if we try to extract its square root, you'll have 4, which is our second term. On the other hand, we have here negative 56m. So remember the rule 2ab. So if we try to consider this as A and this one will be B, so we will be having 2 multiplied to 7m multiplied to 4. So this will be the particular equation that you'll work with, expression that you'll work with to get the negative 56m. Since you have a negative sign here, you will consider negative value. So 2 times 7m, that would be 14m, multiplied to 4, that would become 56m. So it followed, or it complied with the rule of the 2ab. That means it's a perfect square trinomials. So another example, we have here 25y squared plus 70yz plus 49z squared, which is obtained in evaluating 5y plus 7z squared. So if we try to extract the square root of the first term, which is a perfect square number, by the way, we'll have 5y, which is the same as the first term. And then the other one, so this is 5y. The other one is also a perfect squared number. So if we try to evaluate the square root, you'll have 7z, which is the same with the second term. And then rule of 2ab. So 2ab rule. Again, this is 5y. The other one is 7z. And then rule of 2ab. So rule of 2ab, this will become 2. So this will become 2 multiplied to 5y multiplied to 7z. So if we try to multiply this one, you'll have 2 multiplied to 5y, that's 10y, times 7z, that would be 70yz. So therefore, we can consider this one as a perfect square trinomial or a PST. So remember, again, the 3 qualification for a polynomial to be considered a perfect square trinomial. Of course, the first term and the last term should be perfect squared, and then the middle term should comply with our rule 2ab. So that will be the first thing that you should be mindful about when we talk about factoring of perfect square trinomial. So you should be able to identify first if given examples are perfect square trinomial. So let's try this one. Factor m squared plus 4m plus 4. So before we go on with the factoring technique, we should first identify if this particular example is a perfect square trinomial. Is the first term a perfect squared number? Yes. Is the last term a perfect squared number? Yes as well. But will the middle term comply with our rule 2ab? Let's see. Extract the square root of the first term. The square root of m squared is m. Extract the square root of the last term. Square root of 4 is 2. And then 2 multiplied to m multiplied to b. Will this be the same as 4m? This is 2. 2m multiplied to 2. So will this be equal to 4m? Yes. Therefore, this is a perfect square trinomial and it's factorable by a perfect square trinomial. Now, if you have copied the steps a while ago, you can easily recall that the step is indicating or telling us that to set up the factor of a perfect square trinomial, we should get first the perfect square, or the square root rather, of the first term, and then the square root of the last term. So we will be making use of the square roots of the first and the last terms. So we have the square root of the first term, m, and the square root of the last term, 2. And then you have also can recall that we are going to follow the sign of the middle term. In this case, it's positive. So that is the sign that we'll be assigning to or in between m and 2. And then we'll just raise our factor into 2. And that will be it. That would be the factored form of the polynomial above. Okay, next. We have here 25e raised to 4 minus 30ef plus 9f squared. The first term, again, first things first, we should be able to identify if this particular polynomial is a perfect squared trinomial. 25e squared, e raised to 4 rather, is it a perfect squared number? Yes. If it's a perfect square number, then we can extract its square root, and this will become 5e squared. The other factor on the last term, 9f squared, is also a perfect squared number. So, meaning we can also extract its square root, which will be 3f as 1. So, yan. Meron na po tayong dalawang factors, the factor of the square root of the first term and the square root of the second term. Now, we have a minus sign here, so the middle term should comply with our rule 2ab. So, let's try if this will comply with 2ab. We're going to multiply 2 to 5e squared and 3f. And then we'll see if this one will result to 30ef. We have here 2 times 5e squared, that would be 10e squared, multiplied to 3f, that would be 30e squared f. So is this equal to negative 30ef? So something's missing here. E should have a square root of 2. Therefore, this is not factorable by PST. So again, hindi po siya factorable by perfect square trinomial since it doesn't comply with our tree requirement for a perfect square trinomial. So next, another example, x raised to 4 plus 10x raised to 3 plus 25x squared. Is the first term a perfect square number? Yes. So if we extract its square root, we'll have x squared. The last term as well is a perfect square number, so if we extract its square root, you'll have 5x. We have here the middle term, 10x raised to 3. Let's see if it will comply with the 2ab rule. So we need to see first if this is a perfect trinomial before proceeding to the factoring technique. So 2, your a is x squared, and your b would be 5x. Now, multiplying 2x squared and 5x, will that result to 10x squared? So 2 multiplied to x squared, that would be 2x squared, multiplied to 5x, that would be 10x raised to 3. Meaning, we can factor this one with the factoring technique called your factors of perfect squared trinomials. So, first things first, you get the square root of the first term. In this case, we have x squared, square root of the last term, 5x, and then consider the symbol of the second term plus, and then you just have to raise it to the power of 2. Now, you can observe here, x squared and 5x still has a common factor. And we have discussed a while ago that whenever you have common factor, you need to move out all common factors for the polynomial. So, meaning, x squared and 5x still has a common factor, which is x. So, we need to move out x, and then dividing x squared by x, you'll have x. 5x divided by x, that would be 5. So, you'll have x plus 5. Now, sir, how about the exponent 2? How are we going to put that? Since exponent 2 is enclosed here with the parenthesis, and then you raise this particular polynomial into 2, ibig sabihin po, sa labas din, ilalagay yung exponent 2. Why not here, sir? Why shouldn't we put it here? Because if we put it here, x plus 5 will be the only polynomial which will be raised to 2, which is wrong. We are raising the whole answer to the power of 2 because this is the same as with this one. Okay, so I hope that's clear. Next example, a raised to 3 minus 14a squared plus 49a. Now, as you can observe here, a raised to 3 is not a perfect square trinomial. 49a as well, a squared number, sorry. A raised to 3 is not a perfect squared number. 49a as well is not a perfect squared number. But if you can observe, we have here common factor for these three terms. A raised to 3, a squared, and a. So they have a common variable, a. If we try to move out a, we'll be left with a squared minus 14a plus 49 for the other factor. So you will be considering this one. I'm sorry. So a, you are moving out a. This will become a multiplied to a squared minus 14a plus 49. So we have divided This is 49. So we have divided all of the terms by a to obtain this particular factor. So hindi po natin kakalimutan si a. We will still include a on the final answer later on. So observing this polynomial inside the parentheses, you can observe the first term and the last term are perfect square trinomial. And then if you try to evaluate negative 14a, it will comply with the 2ab rule. That means this particular polynomial inside the parentheses is factorable by the PST technique since it's a perfect square trinomial. That means you're going to extract the square root of a squared, which is a, square root of 49, which is 7. And then you will consider the sign of the middle term. So this is a.
And then with regards to the topic about
Minus 7 squared. So again, let's rewrite that one. Your final answer would be a multiplied to a minus 7 squared. So this will be your final answer for this particular example. So I hope we're clear. Let's see the next one. So problem solving. We have problem LOVE and MATH are squares. The area of LOVE is x squared plus 4x plus 4. If the difference of the area between, or if the difference of their area is 10x minus 5, find the length of their sides. Again, let's try to understand the problem. It says here that the area of the square LOVE is x squared plus 4x plus 4. And then the difference of their area is 10x minus 5. We have here the term difference. So that means we will be involved with subtraction as our operation later on. And then we are going to find the length of the side of LOVE and MATH. So this is a common problem. These are squares. So that means all of their areas are equal as well as this particular square. So all of their sides are equal. So let's have first, since the area of the rectangle or the square rather, LOVE is x squared plus 4x plus 4. It's given already. We can factor this one out using, so area of the larger square is equal to x squared plus 4x plus 4. And you can observe here, this is a perfect square trinomial. That means if we try to factor, we will have, this will be equal to x plus 2 squared. So x plus 2 squared or x plus 2 squared rather. So that means if we try to get one area or one dimension of square LOVE, we'll be having x plus 2. Since it's squared, you have two sides. Since the area naman of a square is s squared, that means this is your side. You'll consider as this a side. That means x plus 2 will be the measurement of the side of square x or square LOVE. So I hope we're clear with that. And then we're yet to find the dimension of, or the side, measurement of the side of square MATH. So how are we going to find that one? We are not given the area of the square MATH. Now, what we're going to do, but we're given the fact that the difference of the area of the two squares is 10x minus 5. That means the area of the larger square, so the area of the larger square minus the area of the smaller square, smaller square is equal to 10x minus 5. And then we are given the area of the larger square, which is x squared plus 4x plus 4. So we just substituted this one since it's also equal to x squared plus 4x plus 4. Minus the area of the smaller square is not given. So meaning we'll just assign a as s, area of the smaller square, and then we will just copy 10x minus 5. Now, we are going to find the area of the smaller square. So, just like what we are doing when we try to solve for a missing variable, we need to transpose the area of the smaller square to the other side, and then we will isolate as well 10x minus 5 to the left-hand side for us to arrive at the answer. So, we'll just copy x squared plus 4x plus 4 here. And then from positive, this equation will become negative since it crossed the equal sign. So this will become minus 10x minus 5. And then on the other side, the area of the smaller square is negative here. It will transfer to the other side, so it will become positive. So the area of the smaller square. And then we're going to evaluate this one. So x squared plus 4x, I'll just rewrite, plus 4. And then you have a negative symbol here. You'll distribute that to all of the terms inside the parentheses. This will become negative 10x plus 5 is equal to the area of the smaller square. Evaluating this, you have common or similar terms. This will be x squared. 4x and 10x are common. This will become negative 6x. And then 4 and 5 are also common. Oops, what happened? Here. 4 and 5 are also common, so you'll have plus 9 because we combined these two particular terms since they are similar. That will be the area of your smaller square. Now, evaluating as well the area of the smaller square, you can observe here that this is a perfect square trinomial. The first term is a square or a square number, the last term is a squared number, and the middle term complies with the 2AB rule. So that means it's also factorable by perfect square trinomial. If we extract the square root of the first term, we will have x. The square root of the last term, we will have 3. Consider the sign of the middle term, that would be negative, and then we just square. So this is the same as the area of the smaller square. But since the area of a square is also equal to s squared, and we are just finding the length of the side of square METH, we will have x minus 3 then as the side. So this will become x minus 3. The other side is x minus 3. So I hope you followed that one. If there are any questions, you can write your questions at the comment box, and then I'll try to answer them as soon as possible. So that would be it. Again, if you have questions, please type them on the comment box, and then I'll try to answer them once I read and evaluated your questions. So thank you.